Hello, welcome back. This is going to be a simulation on the flow of a inclined flat plate, and I'm going to be doing 30 degrees for today. So first you'll open up your fluid flow fluent, drag that over, and then once you have that open, you just can click on geometry. Now once the geometry is open, you'll true to the XY plane, and we will begin our sketch. Make sure our units are in centimeters. And then we'll go ahead and change our dimensions and then add an angle. So the dimensions are going to be 30 centimeters long by 0.1 centimeters tall. And the angle, since it's going all the way like this, it's going to be, I believe, 210. Yeah, so it's 180 here, and then we'll go 30 degrees down. Next, we'll draw the volume of the flow. And we'll dimension this. I'm going to do 500 by 500. And we'll center it around the origin. Next, we'll go to Concept, Surface from Sketch, and click on the volume, apply, and generate. Now it'll have it generated except for the rectangle. And then we can close this tab and go to Mesh. Okay. Once it loads in, you'll true to the XY plane again. Go to our mesh and we'll insert a method, click on the main body and apply that. And we're going to be using a triangles method, generate that, and we should have something like this. You'll notice that the rectangular plate has been erased. In order to fix that, you'll drop down the menu for sizing, and it'll have mesh defeaturing selected as yes. We'll change that to no. Generate, and you can see here now it's actually within the mesh. Alright, next we'll right click, insert inflation. And we're going to inflate around the plates of the rectangle. So we'll do the geometry as the main body, and then our boundaries are going to be the actual plate. So control and select all of the faces of the plate. Apply, then you'll have 4 edges. We're going to do a maximum layer of 5. And generate. Once that generates, you'll see that there's the inflation around the plate. Zoom back out. Oops. And then we'll right click, insert sizing. And I'm going to do the inlet sizing and make it a little bit more fine on the inlet and the outlet. So again, control, click the faces, apply. Now for the element size, we are going to be doing 0.1 for the inlet and outlet, and then I'm going to turn off the growth rate, and turn it to hard, and generate. So now you can see it's a little bit more fine on the inlet and outlet. And lastly, we want to make this a little bit more fine as well. So we'll insert another sizing specifically for the rectangle. And apply that. You'll have the 4 edges selected. Next, we'll do element size. We'll do this to the negative 3 power, and again we'll turn off the capture curvature and make the behavior hard in order so that when the flow goes over the rectangle, it's not going to cut the edges. And once you generate that, you'll see that it has a nice fine mesh with some inflation on the edges of the rectangle. And we can zoom all the way out. And that's what our mesh should look like. Alright, so now what we're going to do is we're going to name all of our edges. Click N, call this the inlet, outlet, and then we'll do the top and bottom with control and call this the symmetry. Now I'm going to zoom back into the rectangle. And we'll call this the front plate. And there we go. Alright, now we'll zoom back out. And I always like to check that my name selections are correct. Inlet, outlet, symmetries, both front plate, top plate, back plate, bottom plate. Cool. Now we can exit out of this. We will update our mesh. And we'll begin our setup. Double precision. I have all set 4 processors to run it, so hopefully it goes a little bit quicker. And then this is going to load in your entire mesh. Okay, make sure that this loads in correctly. First we'll begin with our model. We're going to be running the K epsilon model for this simulation. And then we're going to be doing enhanced wall treatment with pressure gradient effects on. Next we'll go to our fluid, and I'm going to be changing some of the characteristics of air. We're going to just round down to 1.2 on the density. We're going to round up to 1.8 to the -5 for viscosity, create and change. After that we'll go to our boundary, and for this simulation I'll be running 15 meters per second for the inlet. Apply that, close, and we want our reference value from the inlet. Now our length of the plate is going to be 0.3 because it's shown in meters here, so just convert the 30 centimeters to meters. And then our area is going to be 0.3. Reference zone is the body. Now we're going to change some methods. The scheme, we're going to do simple. Pressure is going to be presto. Momentum is the first order upwind. And then we'll go to initialization, initialize that. Run calculation, 1500 iterations for this one. And then let that go. This one usually iterates quickly, So we'll see what it lands at. Perfect. Alright, so after this we can go to reports, do the drop down menu and click on forces. Now highlight all of these so that you can see the values for at each portion of the respective plate. Again, that's the rectangle here. And we'll print that. And what it does is, make sure it's on forces as well, because that's what we want to see. And what this does is it'll print in the console down below your respective forces, so pressure and the viscous, and then the total overall forces along with the force coefficients for each. And then it'll show you which zone that it's located at. Now for my project, I actually just copied this into an Excel and made a nice table for it that I'll use for my report. But yeah, that's how you find the forces. So now we'll minimize this and go to our results. Alright, true to the XY plane again. And let us start with the contour. So I will do the velocity contour first. Location is going to be the symmetry. And we'll be doing the velocity. And I'm going to do a pretty high contour, so we'll do 750. That's weird. Oh, symmetry 1. There we go. Makes more sense now. Okay, and that is going to be the first contour of the velocity. Let's change this legend too, because I don't like how it looks. We'll change it to horizontal, variable, parents, drop it down. Oops, wrong way. Fixed to get it up and out of the way. Make this a little bit bigger. I don't know. There we go. So you can see the velocity, high velocity as it hits that front edge and goes over, and same for the lower edge. And we have a pocket of low velocity in the wake region. Alright, so we will repeat this again, however it will do the pressure contour. So I unselect the velocity, then we'll make another contour. Okay, and the same thing, symmetry 1, pressure, we'll do like 750, and boom. Your legend's already changed since I did it last time. And this is a nice representation. You have your stagnation point right about here, high pressure, and then you have your low pressure zone in the wake of the flow, since it's coming in the inlet from the left to the right side. Alright, so we'll unselect that again. And lastly, I will show how to do the vectors. I usually call this the velocity vector. Again, symmetry 1, and apply. This one's a little bit easier. And now you can see the velocity coming in, hits that point, kind of goes up around where it'll go down, and then you have your nice mixing of the turbulent flow. And there you have it. So that is the vectors, the velocity contour, and the pressure contour for a 30-degree plate. Now if you want to do a different angle and you want to do it pretty easily, what you can do is you can go to your geometry, or back to your workbench, go to geometry, right click that, and duplicate. It'll take a second. And now what it did is it essentially copied everything from this one, made a duplication of it, and then what you'll do is you'll go to that geometry of the new one. And you'll see it's already been created. However, let's say we want to change the angle. So we'll go to this, zoom in, Okay, so instead of 210, let's say we want to make it like, I don't know, a 40-degree angle. We'll go to 220, slightly larger angle, generate that, and that's literally all you have to do. So now what you do is you exit out of the geometry, come back to your mesh. Actually, just you probably go to the results, honestly. Update. It'll take a second to go all the way upstream since it's doing the meshing, the setup, everything. Actually, now that I'm thinking about it, I might have done it wrong with the results. I might have to fix that. We'll see. Right now it's updating solution. Yeah, okay. Okay. We'll go back to our setup. Open this one. So I was wrong. You can't update the results. You'll have to go to the Fluent again and calculate it, obviously. Yeah, I messed it up. Anyway. Just update the angle, then update your mesh. You'll go to your setup, make sure that all the settings are the same, and then you run your calculation that way, and then it'll produce the results for that 40-degree angle that you changed it to. And that is all there is to it. Thank you for watching.